SpaceX, a name that has become synonymous with innovation, risk-taking, and the relentless pursuit of the impossible. The name conjures images of fire and ambition, a dream to reach the stars led by Elon Musk, whose vision has redefined what's possible in spaceflight. To take humanity to other worlds, he needs a new kind of ship, Starship. This is not just a vessel, it's a symbol of hope for a future among the stars. This isn't just another rocket, it's a leap forward in design, scale, and ambition. It's designed to carry people to the moon, Mars, and beyond, opening the door to a new chapter in human exploration. Every Starship launch is a global event, a test of human ingenuity and our relentless desire to explore. The world watches, united by curiosity and hope. A rocket launch is a battle against gravity, unleashing power that shakes the ground and lights up the sky. It's a moment where science meets spectacle. SpaceX has turned this spectacle into a regular display, but behind the light and sound lies a profound challenge, one that pushes the limits of engineering. Every launch is a dance with danger, managing energy on the edge of chaos. Each second is a test of precision and nerve. For Starship, the challenge is even greater because of its revolutionary engines. The Raptors, designed from the ground up for deep space travel. These are the most powerful rocket engines ever built, the heart of the machine, capable of propelling us farther than ever before. The dream of becoming a multiplanetary species rests on these engines. Their success could change the course of human history. It all comes down to the first seconds of ignition, the moment of truth when everything is on the line. Pure potential energy is converted into controlled force as tons of metal and fuel come alive in a symphony of engineering. If it goes right, a new voyage begins. The dream of interplanetary travel takes flight. If it goes wrong, the dream can be lost in fire. Years of work can vanish in an instant. The story of the Raptor engine is about mastering this critical moment, turning risk into progress. It's about turning a potential explosion into a controlled ascent, transforming danger into opportunity. Each launch is a test of engineering, courage, and vision. It's a testament to the human spirit. The stakes are enormous, but so is the promise. The future of space exploration hangs in the balance. Starship's success is the next giant leap for all of us, a step toward a destiny beyond Earth. The roar of its engines signals the dawn of a new era, echoing the hopes of generations, and it all starts with the ignition, a spark that could change everything. Elon Musk calls starting a rocket engine a controlled explosion, and he's right. The phrase captures the sheer intensity and danger of what's happening inside every rocket at liftoff. Imagine lighting a barbecue, but with the most powerful fuels known to science, liquid methane and liquid oxygen. These aren't just cold and volatile, they're stored at cryogenic temperatures, making them tricky and dangerous to handle. These fuels want to combine in a violent reaction, releasing an enormous amount of energy in a split second. The engine's job is to control that violence and turn it into thrust, channeling chaos into forward motion. The line between a controlled burn and disaster is razor thin. Even the smallest error can have catastrophic consequences. The fuels must be injected at exactly the right time, in the right amounts, at the right pressure. Precision is everything. Too much fuel before ignition? That's a hard start. A catastrophic event that can destroy the engine and rocket in an instant. The ignition sequence is the most nerve-wracking part of any launch. Every second is filled with tension as teams watch for the slightest anomaly. Temperatures inside the Raptor's chamber reach over 3,300 degrees Celsius, with pressures hundreds of times greater than atmospheric. The environment is utterly unforgiving. Every Raptor must perform this dangerous trick perfectly, in harmony with the others, or the mission is at risk. The Super Heavy booster has 33 engines, each one a potential point of failure. All must ignite within milliseconds, perfectly synchronized, or disaster could strike. If one fails, it could trigger a chain reaction and doom the mission, risking years of work and millions of dollars. This is rocket science at its most unforgiving. Every launch is a test of human ingenuity and engineering. Success is measured in milliseconds, failure in fireballs. The stakes could not be higher. What makes starting the Raptor engine so much harder than older rockets? The answer lies in its revolutionary design, which pushes the boundaries of rocket engineering and demands new solutions to old problems. Traditional engines use a third chemical to ignite, like a match to a candle. This method is reliable and has been used for decades, but it adds extra complexity, weight, and potential points of failure to the system. Raptor, on the other hand, uses a spark ignition system, similar in concept to a car's spark plug, but scaled up to an extreme degree. The energy required is immense, and the precision must be flawless. Methane, Raptor's fuel, is much harder to ignite than kerosene. This means the engine demands perfect timing, higher ignition energy, and absolute control over the fuel mixture to achieve a successful start. Raptor is a full-flow staged combustion engine, meaning all the fuel and oxidizer pass through the pumps before entering the main chamber. This design maximizes efficiency and power output, but this also creates a complex, high-pressure web of pipes, valves, and pumps, where every component must work in perfect harmony. Even the smallest malfunction can cascade into disaster. The startup phase is especially sensitive. Tiny errors in timing, pressure, or a single valve can have massive consequences. Every millisecond counts, and there's no room for mistakes. It's like starting a high-performance race car, not a lawnmower. The stakes are higher, the tolerance is tighter, and the margin for error almost non-existent. The power unleashed is immense, but so is the risk. Every test is a leap forward, but also a reminder of the dangers involved. The reward? An engine that could change the future of space travel, making new missions possible and opening the door to Mars and beyond. But all of this potential only matters if the engine can be started safely, every single time, without fail. To meet this challenge, SpaceX is constantly improving its engine. The latest version, Raptor 3, is a masterpiece, more reliable, more powerful. The goal, not just more thrust, but safer, more predictable ignition. Raptor 3 removes complex parts. Simplicity means reliability. The engine is stronger and lighter with smarter design and fewer weak points. The ignition system is more robust, refined by mountains of test data. Improved injectors ensure a perfect fuel mix for smooth startup. The result? An engine with greater margin for error, ready for the extreme conditions of launch. Raptor 3 is the culmination of years of trial, error, and relentless innovation. Fixing the startup problem is SpaceX's top priority. At their Texas facility, every engine test, success or explosion, yields vital data. Rapid iteration is their secret: build, test, break, learn, repeat. The focus is on perfecting pre-chill and spin prime phases, cooling the engine and spinning up pumps before ignition. Even a millisecond error, a sticky valve, a faulty sensor, a missed spark, can cause disaster. SpaceX is developing smarter software and stronger hardware to catch problems before they cascade. Advanced algorithms can detect issues and shut down engines safely. The goal makes starting 33 Raptors as routine as starting your car. It's a monumental task, but SpaceX is relentless. Each test brings them closer to reliable, safe ignition. The future of Starship depends on it. Raptor ignition isn't just an engineering detail, it's the key to the future of space exploration. Starship's vision of rapid, full reusability depends on engines that start reliably, every time. For Mars missions, reusability is essential. Starship must land, refuel, and launch again, even on another planet. Imagine a Starship on Mars. If the engines don't ignite, the crew is stranded. The stakes are life and death. Raptor's use of methane, which can be made on Mars, is a game changer. In situ resource utilization means Starship could refuel on Mars and return home. But none of this is possible if the engines can't be trusted to start. Every ambitious plan, lunar bases, Martian cities, depends on mastering this one technology. The controlled explosion must become routine, safe, and dependable. That's the difference between a museum piece and a vessel for humanity's future. Perfecting the Raptor engine is about turning chaos into control. It's harnessing violent chemistry with precision and grace. Every test, every launch teaches lessons for all of humanity. Like early aviation, each failure leads to better engines and safer systems. We're at a turning point. Taming the Raptor is part of making spaceflight safe and accessible. When this problem is solved, the cost of reaching orbit will plummet. Space will open to scientists, entrepreneurs, and eventually, ordinary people. The Raptor's fire will become the heartbeat of a new space age. It represents ambition, curiosity, and our refusal to accept limits. Setbacks are inevitable, but each successful ignition brings us closer to a future once only imagined. We're learning to master the fire and our destiny among the stars. The roar of the Raptor is the sound of a new chapter for humanity, and it all begins with a spark.